Share my screen. And then, yeah, no more writing answers on your quiz, but get yourself ready to go over the quiz. Is that a question for you? Question is, where do I post the recordings of the lectures? Under the Issues tab on our GitHub webpage. Way down at the bottom, there is a link to Zoom and lecture information. If you click that, then there is a YouTube playlist right here that you can click on, and all the old lectures are there. Yep. Okay, let's come back together here. So 5 problems on the quiz. Problem number 1 right here, using this enumerate function. We didn't actually get to using the enumerate function in class here. And that's a little bit intentional on my part, a lot intentional actually. And the purpose of a lot of the things I do in class here, or a lot of the things that we do together in class, is so that you have to look things up on your own and get comfortable finding out things on your own, either via the textbook or Googling or whatever resources that you want. And this enumerate function is an extremely common thing, used all the time in Python. And the idea of this enumerate function is that, let's just do next. So here we're on the for loop over here. And now over here to the left of the in, we have 2 variables that are going to be created for me in my for loop. I'm going to be looping over 2 things at once instead of only one thing. Here the I again for index. It's not required to be named I, but all good programmers use I for indexes. And then char, this is going to be the actual character of the location at that particular index, the value at that index. And so if I want, it's very common with for loops to need both the value and the index at the same time, and the enumerate lets you do that in sort of a nice, clean way. So extremely common pattern in Python. Probably more than half of the for loops that I write in practice use this enumerate function, looping over both the index and the value at the same time. Notice over here on the right-hand side of my global frame, there are 2 variables currently defined, the sentence and the accumulator. And as soon as I press next right here, then 2 new variables instantly got defined, the I variable and the char. I is the index, P is the value at that particular index. So in this string right here, Python, the value P, character P at index 0, that's where both of these 2 things are coming from. And this code right here comes almost exactly from one of your practice quiz problems, except that this if statement right here, the condition is just mildly different, and the thing that we're accumulating right here, just mildly different. And so here what I'm checking, if the character is equal to star, then we'll, and this other thing matches, then we'll do this thing here. Otherwise, if the character is equal to star and this thing over here didn't match, then we'll do this thing. Otherwise, we'll do this. So just looking at this, I know that I'm going to do this thing down here the vast majority of times, because the vast majority of these characters are not equal to the star. So just my prediction right now, character is not equal to star. So skip that if statement, skip that else statement down here into the else, and the accumulator will get plus equal char. So just getting the P right here. And that's going to happen all the way up until I get to the star over here. So I'll just press next a bunch of times. There's a lot of steps to this particular problem, but most of them are things that you can just kind of skip over without having to manually think about them each time, because they're basically the same for each iteration of the loop. And now we're getting the first situation where we have something more interesting happening. This character right here is the star. The next thing that we're looking at is the star. And so we're not going to be into this else statement. We're going to be into one of these. In this case, so sentence, this is where I'm using both the index right here and the value at the same time. So here the value is star. When I look at sentence, square bracket, I minus 1, this is the value at the previous index. So char is sentence at position I. This is sentence at position I minus 1. At position I minus 1 is going to be equal to the space right here. So it's not equal to the star. And so we should go inside of this loop. And there we go. We do go inside, inside this if statement. We do go inside the if statement here. And now the accumulator is or adding to it an empty string, so not doing anything basically. We'll see if the accumulator doesn't change. And so it's basically removing that star from the string if the previous character was not equal to a star. Again, not at star, so skip through that quickly. Up to another star right here as our next character. The previous character, we sort of said that the semantics of this is look at the previous character if it's equal to a star or not. And in this case, it's not equal to a star again. So we'll be in this first iteration, just doing nothing, removing that star from the string in that accumulator. And that's going to happen a whole bunch of times. We'll either be removing the star or just adding the character until we get to the very end. Fun. Here's the last 3 stars. The first of those stars will go inside this if statement right here, not do anything. But then the next star position is at this star right here. The very previous one is in fact a star. So finally we get to come inside of this. This up here is going to evaluate to false. And so this part right here remains as true. And so I'll go inside and do this accumulator right here, adding an exclamation point. And so Python is fun. Bang, bang, print it out. Python is fun is the answer for number 1. And we can now breathe. Any questions on the first problem? Okay, so high-level takeaways here again. This enumerate function, super commonly used in Python. So that's one high-level takeaway. Another high-level takeaway is that as we get to these more and more complicated pieces of code, as you see patterns that are appearing more and more often, your brain can start, or you can start not necessarily evaluating each line individually one at a time, but kind of finding these patterns, figuring out, okay, I know the big picture idea of what each iteration of this for loop does. And so without thinking about each one of these individual steps, I can just do that big picture idea in one go. And the more you're able to think about like the big picture idea, consolidating multiple lines of code into like a single step in your head while you're thinking through it, the easier reading larger pieces of code will become. Any questions on the first problem? Okay. Problem number 2. All the other problems are somehow about list comprehensions. And again, list comprehensions are a shortcut for the accumulator pattern because the accumulator pattern happens so often in not just Python, but every programming language. And this is also the reason why we're talking about it at this point is because it was potentially a very useful thing for you to use in your previous homework assignments. So here, let's see, maybe step back for a second. One of the sort of frustrating things I find about pythontutor.com and actually all web pages is that web pages change. Like I can't just go back to last year's version of pythontutor.com. But in this case, I really wish I could because last year Python Tutor would jump when it saw a list comprehension. It wouldn't try to like do this step by step. It would just go straight to line 2 right here. But this year's Python Tutor, I don't know, there's a whole bunch of steps here that are basically meaningless. Like I know what they're trying to say under the hood here with all these things, but it doesn't help me understand the list comprehension in any way. So this is all a whole bunch of like super useless stuff. 8 steps that I had to step through until I got to the actual value of this list comprehension right here. And that's really what you want to do. Anytime you see a list comprehension problem or you're writing out a list comprehension for yourself, you want to be able to take this and think about what are the actual values in this list. Coming up with this yellow thing over here, what are the actual values in this list? Semantically, what this list comprehension is saying, so range 4, that's 0, 1, 2, 3. And we're going to modify that with this computation right here. The thing to the left of the 4 again is the computation. The thing to this over here describes what we're looping over. And so we're looping over all the numbers between 0 and 3 and then multiplying them by 2. So that's why we get 0, 2, 4, 6. Sort of making, just stretching out that the result of the range. And then down here, our next line is going to add all of those things together. So 2 plus 4 plus 6. Press next. And we get 12. It's 2 plus 4 plus 6. And so that's the answer for number 2 is 12. 2. So again, the hard part of these list comprehensions is just coming up with what is the actual list that corresponds to the comprehension that you're given. Any questions on problem number 2? Okay, all these problems that we're going over, again, I'm going to think about them and talk about them from a semantic sense, because that is the end goal after you're programming with Python for a long period of time. You run through these list comprehensions, see them a lot. You want to be thinking about them at the high level, the meaning of them. But again, that's shortcut for the accumulator pattern. So you can always just, if you're confused, not 100% sure on the semantics of it, what it means at a high level, you can always just replace it with the accumulator pattern and evaluate it that way, and perfectly good. Okay, next problem. Here we have a significantly more complicated list comprehension. It's more complicated in 2 ways. Well, the computation is the same right here, but the for loop itself right here is more complicated because the range is more complicated. And so you'll have to evaluate exactly what this range is right here. And then it's more complicated because we're using a more complicated accumulator pattern that actually has an if statement about what we're going to do. I'm going to break this up into 2 steps to think about it. So I'll just edit this code real quick. And I'm going to create a temporary variable over here that's just going to contain the range numbers so that we can think about what are we in fact looping over. I'm not going to modify the code down here that's actually running stuff. I just want to see what is this range right here that I'm looping over. And so we'll visualize that. Press the next button. So this is the result of that range function. These are the numbers that our x is going to take on as I loop over range. -5, -2, 1, and 4. We start at -5, go up to not including 5 with a step size of 3. So -5 plus 3 will give us -2, plus 3 give us 1, plus 3 give us 4, plus 3 gives us 7. 7 is outside of the range, so we don't include 7 and stop. So those are the 4 values that we'll be looping over right here. Now this if statement over here is a little bit tricky, that we have if x %2. So x %2 is going to evaluate to an integer. Again, it'll evaluate to 0 whenever x is even. It'll evaluate to 1 whenever x is odd. And this right here is equivalent. I'll go back to editing this code so that we can remind us about the truthiness that if x %2, do it without the if, that is equivalent to x %2 equals 1. That if something is 0, that is falsy in Python. If something is non-zero, then it is truthy. So Python programmers in some situations pride themselves on writing code that is easy to read. This is not one of those situations. In this situation, Python programmers pride themselves on writing code that is short. And so it's very common to leave out the equals 1 here and just rely on truthiness and falsiness. So here, the filtering of this list is going to remove all of the even elements for us. I'm going to do a thing that you may or may not have noticed about Python Tutor before. So you've probably noticed that as I click lines, things turn red. What is the meaning of that redness? Now, when I press the next right here, it's going to keep running up until it hits the red line right here. It's going to keep running up until it hits the red line. The red line is called a breakpoint. If I didn't have that, then it would step through this entire comprehension one at a time, doing all those unnecessary steps. But by putting the red line there and pressing next, it'll just jump ahead to the next red line that it sees. So it hasn't evaluated this line yet. It's just now actually evaluated this list comprehension. We have these two values down here. We said that the filtering up here removed all the even values. So it removed -2 and it removed 4, kept -5 and 1. And then we apply this computation multiplying by 2. -5 times 2 is -10. 1 times 2 is 2. And so this is the final list that XS is equal to after applying all of that comprehension stuff. What the problem's actually doing next, though, is taking the length of that list. Next, the length is just 2, and we print that out. And so that's the final answer is 2 for problem number 3. Talked about a lot of different things in that problem, and I went very fast. Okay, if some of it went over your head, but are there any questions about this problem at all? Sure. Question is truthiness and falsiness particular to Python? And the answer is that Python programmers are the original people who introduced like truthiness and falsiness to the world. Python programmers sort of like fully embrace this idea of truthiness and falsiness as a community. They use it in a lot of places. There are other programming languages, though, that have something equivalent to truthiness and falsiness inside of them. But it is, their rules for what makes something truthy versus falsy are different than Python's rules. Yeah. So short answer is that for our purposes, truthiness and falsiness is a Python specific thing. And certainly like in HTML or CSS, there's no like equivalent to that because there's no equivalent to like if statements or any of those control structures. Good question. Any other questions so far? Problem number 4. Here we go. Yep. So I have the answer already listed up here. The trick to this one, or the way that I would evaluate this one, is that I would notice that down here I'm only printing out the length down here, and since I'm only printing out the length, then like I don't actually have to do any of these computations right here. That like whatever this intermediate thing evaluates to, this again is a list of a list, comprehension of a comprehension. Here's the inner comprehensions. I don't need to waste my time thinking about like, is this middle list a 001 or a 001112 or any of that stuff? I don't need to care about the lengths of these lists. All I need to know is how many lists are there in this outer list right here. I don't go inside. I don't go check the length of these inner lists when I'm asking about the length of this outer list. And so all I have to do, I can totally ignore this part of the comprehension and just look at, okay, what am I looping over? Well, there's these, what is that, 5 elements right here. Here's my condition that I'm applying to see whether it is true or false. In this case, I made the truthy condition explicit, but this would be equivalent if I had taken that out. And so I can just apply this, find how many odd elements are there up here. Well, it's only 3 and 5, so there's only 2 odd elements, and just write the number 2 without having to do a lot of steps. It's okay if you want to perform a lot of steps. This list, there's 25 steps that Python Tutor evaluates to do this, but you can do it in basically just one step in your head if you realize that you only need the length of the list instead of doing the actual computations right here. So that's problem number 4. The answer was 2. Last problem. Yes, question.
Well, could you still explain how I divided by 2?
Question is, okay, so in this problem, we didn't actually need to do this computation right here, I//2, but still I'm curious about why I//2, why this computation right here gives me these results over here. The answer is that, so this is sort of a review of the very, very first Python quiz that we had, and to do this, I'm gonna switch over to VS Code for a second and enter interactive Python. And if we have, say, 1 divided by 2, that gives you what you would expect, normal division. The type of 1 is an integer, but the type of 1 divided by 2 is a float. Float is Python's word for decimal number, 0.5. And when you do the slash like this, you get the decimal number as the output. If you want an integer as output, then you do integer division. Slash slash gives you integer division. And the way integer division works is that it computes the floating point division like this, and then truncates the decimal over here. So 1 slash slash 2, it first computes the 0.5, and then take away the 0.5 to give you a just 0. And so yeah, now the type is an int because it's integer division. The value is going to be 0. So 0 slash slash 2, 0, 1 slash slash 2, 0, 2 slash slash 2, 1, 3 slash slash 2, 1, and so on. And so if I have I slash slash 2 for I in range 5, like that, then that will give me these numbers right here. Consider all the numbers from 0 up to 4, all the numbers up to, but not including 5. Do integer division by 2, and so these are the corresponding numbers to these, dividing them by 2. Does that answer your question? Good question. Is that also a question?
Yes. How do we know that, well, how can we tell that the code is putting, is defining XSS as a list of 2 lists and not just a list of 8 items?
Yeah, here's a great question. So the question is, let's copy and paste this into VS Code for a second. There we go. And XS, what were you equal to? 2, 3, 4, 5, 6. And the question is up here when I do this, how did we know that this was a list of lists instead of like just a single list with all these different items inside of it? The answer is when I look at this, I see there's 2 square brackets right here. That if I had just a single for statement like this, and just a single value over here, I'll just put none as a placeholder, then I'm going to get these 2 things out, that it's the computation right here. This computation corresponds to the values that come out in this final list down here. Put an X right here. These are the particular values that I'm looping over inside the XS list that pass this filter, that are odd. XS is the numbers between 2 and 6. Only 3 and 5 are odd, so only 3 and 5 pass this filtering computation right here. And then this computation here can be any arbitrary computation that Python can do. And so the examples that we're looking at right now are all, they're giving out individual values. They're giving out simple data types, not containers. Simple data types, not containers. But I could put another list comprehension inside of it, or maybe I could just put an empty list like that. We'll start with that. Now we have a list of lists where the contents are empty lists. I could make them 1, 2, 3. Now the contents is 1, 2, 3 at each one of these locations. But more generally, it would be rare to want to hard code something like this, hard code a list inside of a list. More common to use a nested list comprehension and do it. Here's what we actually had. I divided by 2 for I in range X, like that. And now each individual thing is a list. It's this computation right here. If I had that just by itself, that would give me an error because X is not defined, but replace that with 3 or with 5, and that gives me the individual entries inside of that bigger list. Does that answer your question?
Yeah.
Great question so far. Any other questions on problem number 4? Problem number 5, last problem. And we have the answer. I forgot to go back, already listed up there. The key idea of this problem, again, this is one that you could step through line by line. But the key idea of this problem is that when I look at this list comprehension down here, I look at the condition over here, and I want to think about, can this condition ever possibly be true? And the answer is no, because over here on the left-hand side of n, I have a capital T trump, a capital T trump. And it is true that there are capital T trumps in the text of the tweet at various locations up here. But I'm not looking at the text of the tweet, I'm looking at the lowercase version of the text of the tweet. And so the pattern that you actually want to do when you're doing something like this, edit this code. What this should look like is lowercase trump in tweet of text like that. That will actually tell me how many trumps there are. And if I were running that, then that would give me that there are 4 tweets that contain the word Trump, but that's not what the problem asked. The problem had that typo in it, and so for the purposes of the quiz, the problem's answer was 0. There's an extremely common mistake that I see students make all the time, both in this class and follow-on classes, is that you're looking inside of a string that you've made explicitly all lowercase, and you're looking for uppercase words inside the lowercase string. And I've seen students spend, like, I don't know, literally a dozen hours trying to figure out why their code doesn't work because of a problem like this. So paying attention to these upper and lowercase strings, very, very important thing to do to catch bugs, catch mistakes. So again, problem number 5, the answer is 0. Go ahead and total up your points and get your quizzes passed up to me somehow. As you're doing that, yeah, if you didn't get both of the practice quizzes for next week, there's 2 of them up here. Make sure that you get those. Are there any other quizzes that I should have? Okay. So the 2 quiz files, the format for the upcoming quiz is going to look slightly different. That I'm just going to give you raw Python files. That'll be a little bit easier to work with and talk about. So we're going to be going over these here in a couple of minutes. If you want to have them on your own computer and work with them, which you should definitely do before taking the quiz in order to study for the quiz, it's these 2 files right here. We're in the Topic 8 Python web scraping folder this week, and it's the bs4 practice quiz and practice quiz 2.py file that we'll be going over. Again, you're not allowed to use the electronic things on quizzes. You are allowed to use whatever handouts you want, so having these handouts with appropriate notes on them is a good idea for next week. But using it electronically in VS Code is the way to practice. What we've been talking about, so yeah, we're building up to web scraping. Last time we talked about a number of different libraries and techniques in Python for getting strings, getting information into Python. And the key takeaway from that in our notes.py file, if we scroll down here to the very bottom, it's that when you're like loading data, it doesn't matter where you get the data from. The only reason we have different sources of getting different ways of getting data from different locations is because we just have data stored in different places, on your hard drive, on the internet, on the command line, lots of different places. But which processing method you choose, it doesn't matter where the data comes from. Python always gets that data in, and you convert it to a string, and then you can do whatever you want to it. Doesn't matter where you get it from. So that's the big takeaway so far, is that all the string processing stuff we've been talking about, you can apply all of that to the web pages that we're going to be scraping, and things will just work. Your next assignment is posted. Project 3, scraping things from eBay. And we're going to do things a little bit differently for this assignment. I'm not going to talk explicitly in class, except for like this 5 minutes right here. I'm not going to talk at all about this assignment. Instead, there's a video here that I recommend you watch about completing the assignment. It'll go over some of the high-level ideas of the assignment. And then it has me like live coding my like 80% complete solution to the assignment. So you can follow along with that, get a mostly complete working solution to the assignment, and then you'll have to extend it in certain ways to fully complete the assignment. But what I will say about this is if you come over to like eBay and you search, say, for welding mask, then there's a bunch of different welding masks on eBay. They all have different prices. And this data would be very useful to a company that is maybe manufacturing welding masks or distributing welding masks, and you want to know like what are the competitors selling things for so that you can effectively price your products. But the way eBay is formatted, you can't actually like have raw data to this. There's no Python function that you can call that's just going to tell me that this particular welding mask is $14.79. And so your scraping program is going to extract all this information and put it into a JSON file. And then that JSON file, we have lots of good techniques for analyzing those, plotting the information, for example. And a business analyst could do that and get nice graphs, present that information to marketing teams or other people to make important business decisions. And actually, I use this welding mask example because my brother he runs a tool company, and one of the things that he sells is welding masks, and he sells them on eBay and Amazon and his own website. And it's about almost 10 years ago now, he got in touch with a new distributor in China who is making new welding masks. And the first thing he wanted to know was like, how much should he price his welding mask when he sells it on eBay? So I scraped eBay for him, found that exact same welding mask was being sold on eBay for $20. And there was one particular seller who was selling about 10,000 of those a month. So it was a very, very high demand item. And it was actually a very high margin item as well. Very profitable because the manufacturer in China was selling them for $10 a piece, and you could resell them for $20 a piece. So when we identified that, huge market opportunity, huge volume. So there was potential like hundreds of thousands, millions of dollars of profit on the table here. And we did that, listed the welding mask for $19 instead of $20. So everybody started buying his welding masks. That lasted for like a week or two until the other company noticed their sales plummeted and listed for $18. And then the price war went down and it settled on like $11, $12 or something. So I don't know, we ended up making, I forget the exact number, but more than 100,000 in profit on that. So good from a business perspective, and also great for a consumer perspective that these very high demand welding mask items, the price went down to a more efficient market price. So very real world, like applicable assignment that you're doing right here. If you're running, like even if you're not necessarily interested in having a high-tech computer science career, but want to start your own company doing something totally unrelated, having these skills to scrape what your competition is doing and understanding it and making your own business decisions accordingly is potentially extremely profitable. So there again, that's the purpose of this assignment. This video will walk you through the details of what you're required to do and complete a lot of the assignment for you. Any questions at a high level at this point? Yes. Question is, when does it due? That's a great question. You have about just under 2 weeks, 10-ish days to complete it. So not this coming Sunday, but the weekend after. Yeah. In general, for all the projects, I try to make sure that it's you have at least a full week to complete it. Great question. Any other questions about this assignment? Okay. Two more things that I'll highlight real quick. just this jumped out to me right here. That notice that the name of the file that you'll be creating is ebaydl.py. This maybe will remind you a little bit of the YouTube dl.py file. And so the thing you're creating is going to have a very similar interface to YouTube DL, scraping things from YouTube. Another common question that students have is like, this seems really cool, but is it legal to take all this information off of eBay or off of YouTube or off of any of these other websites, whoever your competitors might be? And the answer is that the Supreme Court has ruled that this is 100% like no questions asked, fully legal. That anything that a human is able, any information that a human is able to gather from the internet, there is no restrictions on a computer automating that gathering process. There's two famous Supreme Court cases that made this like the de facto law of the United States, and due to the various treaties, it's the de facto law of everywhere in the world right now. And the EFF, Electronic Frontier Foundation, is the organization that is the responsible for providing the legal counsel for these cases. And so they have two good web pages right here, linked here, explaining the facts of the cases and the Supreme Court decisions. So if you're interested in that sort of thing, this is a great articles to read. And then the last thing that I'll say about this is that the EFF, super famous organization in hacker programming circles. It's basically like the ACLU for computer freedom of speech. Their explicit focus is just making sure that freedom of speech on the internet is protected. That they observed that other organizations that had similar missions, like the ACLU, didn't have the technical expertise to do that, and so there was a lot of bad court decisions. And so hackers got together, created this organization to focus just on freedom of speech of the internet. Okay. What we're going to talk about next is preparing for the quiz next week. Before we do that, any questions about anything we've talked about so far? Okay, so for your quiz next week, there's again these two files, bs4 practice quiz 2 and bs4 practice quiz.py. In class today, we're going to go over the bs4 practice quiz.py, and then the practice quiz 2 is intended to give you more practice problems for you to work on by yourself. Here, the bs4 practice quiz.py. At the top, I have this string. It is a string literal because I have quotation marks, and I have typed the contents of this string directly into the Python file. This string literal happens to contain HTML code, but string literals can contain whatever you want them to. And we're going to be using this beautiful soup library to process this HTML code. Again, the main takeaway from last class is that it doesn't matter where this HTML code comes from. That in this case, just for simplicity's purposes, I have hard-coded this into the Python file. But Beautiful Soup will work exactly the same whether this HTML comes from a file that somebody has manually downloaded, or whether it comes from a file on the internet, a web page on the internet like eBay that you have downloaded automatically. And so in your programming assignments, you will use that requests library to download various web pages from eBay, download those different search results to get HTML. And then you'll be using the Beautiful Soup library to extract information from that HTML. And that extraction process is going to look exactly like the extraction process we're doing on this quiz. So in terms of like how to organize your studying efforts, you should first make sure that you fully understand the stuff on this quiz. And then once you have a good grasp on that, then you should go look at the video and work on the project. Because even though we're not like downloading things from a web page here, all the material is essentially exactly the same. These, if you look closely at these HTML files, they might look familiar to you because these are the exact same 2 HTML codes that you had on your very first quiz in this class, where we were doing CSS selectors. And it turns out that the best way to scrape information from a web page is to use CSS selectors to extract the particular information that you want from the web page. And so this quiz is going to quiz you on how to use Beautiful Soup to extract various information using CSS selectors and your ability to sort of integrate this Python with this HTML, with this CSS knowledge, all three of these things working together at the same time to solve this web scraping problem. Let's see, in order to work on these problems one at a time, so you can see right now that if I run this triangle button up here, it's going to print out the answers to all the problems. The answers by themselves aren't super useful though, without actually like talking about how we get these answers. So I'm gonna press the up arrow button here, over here, and add the -I again between Python 3 and my file name to get into interactive mode. It'll print out the answers to the problems up here. And then down here, I'll have access to the different variables in the problem. Each problem, though, you'll notice has the same variable defined multiple times. And so if I were to look at the tags variable, if I want to find out like what is this tags variable from the first problem equal to, then it's going to be overwritten here on line 36. Problem 2 is going to overwrite the information from problem 1. And so I'm not going to be able to have access to this information from problem 1 up here. In order to get access to this information from problem 1, what I'm going to do is I'm going to crash Python after this code right here. I'm going to crash Python right at this point. Easy way to do that is just type in some like gibberish. Python will hit that and it'll panic. Barf out this giant, oh, I guess I have to save it up here. Control S, save down here, up arrow, hit enter, hits that gibberish right there, doesn't know what that means. In particular, thinks it should be a variable, but it's not defined, and it crashes. And so Python stops after problem 1, and now I have access to these variables right here. And as you're working on the practice quiz over 2, working on these various problems, it's a similar thing. So if you isolate one particular problem that you want to work on, crash Python at that point and get into interactive Python on the line, on the problem that you're working on. Question? Question is, can you use what's called a breakpoint? A breakpoint, this is sort of like a breakpoint. It's essentially the same thing. The breakpoint requires a little bit more advanced Python debugging things, which we haven't talked about. So if you want to try doing that, the book does talk about using breakpoints to step through your code one line at a time, basically integrating Python tutor with VS Code, but we're not going to talk about that in class right now. Good question. Since we're talking about Python tutor as well, this is something that you cannot use Python tutor for. All the previous quizzes, you could use Python tutor, but you cannot use Python tutor for this because this requires this external library bs4 that is not built into Python. And so if you try to import this line right up here into Python tutor, it will it'll crash. It'll say it doesn't have access to this bs4 library, and there's no way to install it on Python tutor. So this is the easiest, most direct way to work through this problem. And this is exactly actually what I would be doing in practice. Even knowing many, many more things, this is the tool of choice that I would use. And I use all the time when I'm debugging things. Great question. Any other questions about the problem setup at this point, or anything that we've talked about? Okay. So last time in class, we mentioned that this Beautiful Soup, what Beautiful Soup does is it's, the verb is that it parses this HTML document up here. And again, I'm using document loosely. It's not like a file stored on the computer. It's this string in the Python program, but people still refer to this as a document, even though it's not a file. I'm parsing this HTML document right here into this soup object. And this soup object has this select function built into it. And the select function lets me use CSS selectors to find various entries inside of the HTML up here. So the reason why this function is select, the way that I remember it, is that the dot select function uses CSS selectors. And CSS selectors are called that way because they select certain HTML tags inside the documents. So reviewing our CSS selectors a little bit, if I have just a string by itself inside of here, no fancy punctuation marks, then this is going to refer to a particular HTML tag. It's going to find all of the HTML tags that are the letter A, so all of the links. And if we come up here, if I highlight like that, it'll show me the different HTML tags. Let's move this out of the way, make sure there's none over here. And it looks to me like there's only two. I only see this one right here and this one right here. And so when I run this soup.select of A, get this tags variable, type in tags down here like this, I do in fact get a list with two elements inside of it. This element right here and this element right here. So what this length of tags is doing, the semantics of this call right here, is it's counting how many times did this A tag appear in this HTML up here. And if you recall from the way back when in the very first quiz, that's exactly the sort of question that the very first quiz was asking you, that if you had a CSS selector, how many times did that CSS selector find an HTML tag? Last time, there was an excellent question about like, okay, there's no quotation marks around this stuff in the list. So like, what exactly is this? And the answer is that it is not a string. It is this, so if we get the 0 entry here, we can ask for the type of this entry. It's something that is built into this bs4 library. I know it's built into bs4 because it has bs4 dot over here. And it's, we call it a tag type because it represents an individual tag inside of the HTML document. And these tags have various things that we can do with them, like getting the actual text like this, getting the text of the tag. And so back just real quick over to eBay, if we had a CSS selector, like let's go inspect this real quick. There we go. A CSS selector that somehow extracted this particular tag right here, this particular tag, then I could do that tag.text to get the amount, like what is the price of this of this welding goggle right here. So that's like why we might want to do something like this, why we might want to select a particular tag is because it has information inside of it that we want to do some sort of computation with, and then we can do the .text to actually extract that information. And for the purposes of the quiz is going to be just like the quiz from the first week, where we just count the number of matching tags. I'm not going to ask you to actually extract the text from those tags and print that or something. I'm just going to ask you to do the count. So it'll be reviewing your CSS selectors just in the context of Python. So this problem 1, the answer is 2, because there are 2 CSS selectors or 2 A tags that match this CSS selector right here. Any questions about this first problem? Okay, so coming down here to this next problem, I'll just move my little crashy code down here. And now our CS selector is getting a little bit more complicated. We have the space between things. The space, again, means that this thing over here, the span, must be a descendant of the p tag. And you have your CSS cheat sheet, HTML cheat sheet that you should be referencing as you're completing this assignment in this quiz. And so now I'm looking for all the span tags that are children of or descendants of the p tag. It looks like this one up here is not a descendant of the p tag. This one here is, this one is not. I only see these 3 tags right here, so I think we'll get an answer of 1. In order to rerun this problem, now looking at this second problem right here. I've moved my crash code, save this up here, down here. I have to exit my interactive Python and rerun it. Now it's printing out the answer to problem 2 is 1. And now I can actually verify exactly which one of those tags it was, like this, that it's the class italic with lorem ipsum inside of it. And if I scroll back up to the top, I can verify that that is in fact this tag right here that I thought it was going to be. So that now that we have this Python, a little bit more powerful interface, we can do a little bit more verifying of like actually checking exactly which tag it was that was matching, if there's confusion. Question?
How was that? What did you type into the terminal there to get that in? Find exact tags.
So the question is, what exactly did I type into the terminal to get this this output down here? Every time I'm doing a new one of these problems, I'll exit my interactive Python, make sure that I have my crashy code, whatever it is, after the problem, save the file down here, up arrow, rerun it, and we'll see that the problem 2 now prints out right here. And then what I wanted to see was this variable tags. What are the actual tags that match this particular CSS selector right here? And so I do tags like that, and that prints out the list of all the tags. Did that answer your question? Good question. Any other questions so far? Okay. One of the things that is different about this quiz in terms of CSS from the previous quiz about CSS is that I never asked you before about situations where there are duplicates, but now I am going to ask you about situations with duplicates. So here, the p comma dot bold. So recall that the dot bold means that we're finding classes that are equal to bold and tags that have the bold class. And the comma means that do the thing on the left or match the thing on the right. And if I look up here, there, so let's find all the p tags. I can again select the p's like this. And so I see there are 2 p tags right here, this one and this one. And then if I want to find all the class equals bold, I can highlight that and I can see that, okay, there are 3 things that match the class equals bold. But one of those things is a duplicate. This p tag matches twice. It matches both the p aspect and it matches the class equals bold aspect. So again, this is a key thing that's guaranteed to be on the upcoming quiz that is different about the previous quiz, is that this duplicate will be removed. So I'll save that right here, come down here, exit out of interactive Python, up arrow, rerun it. Now we have problem 3 is being printed. The answer is 4 right here. If I type out this tags to see what are the actual tags that got printed, I can see that inside of here there is exactly 1 p tag that is being matched. This p tag matches this condition for 2 different reasons. It matches because it's a p tag, and it matches because its class is bold. It matches for 2 different reasons right here, but it still only gets included in this final list 1 time. So this, and when you use the comma inside the CSS selector, this will remove the duplicates. And you're responsible for that knowledge. Guaranteed a question like this will be on the quiz next week. Any questions about that?
What was the answer to problem 2?
The answer to problem 2, 1. Yes. Exactly. So the meaning of the comma is or do the thing on the left or do the thing on the right, but don't, if something matches both of them, don't include them both. So the next things that are going to be on the quiz is combining things a little bit more interestingly with Python. All the things up above are, I mean, there's some mild variation compared to the previous CSS quiz. but it's really all this stuff above is just testing solely your understanding of CSS selectors. And then the Python code is basically trivial. Next, though, we're going on to things that are going to test at the same time your knowledge of CSS selectors and your knowledge of Python, especially being able to walk through the accumulator pattern. So here, what we're doing, this very first line, find all the things that match the P selector, all the tags that match the P selector, so all the paragraphs. And then we're going to use this accumulator right here and find all of the for each one of these P tags here, each one of these things, I'm going to loop over it. So looping over all of these tags, for tag and tags. For each one of these Ps, I'm going to look inside that particular tag to find if it has any A's as a descendant. So this is tag.select, not soup.select. So I'm looking only inside of a particular P tag. I know it's a P tag because it's the result of a soup.select P. And then my accumulator is going to contain all of those A tags. We save this, come down here, exit out, up arrow, rerun. We'll see that there's exactly one, again, A tag inside of a P tag. And that's because this code happens to compute the same thing as the PA, which is what we computed above. If I were to look now at the actual tags variable right here, look at the P tags themselves. So look at tags. We can see that tags itself contains only Ps. There's two entries here. Both of them are P tags inside of tags. If I do length of tags, I get 2. So the length of this is 2. This P matches 2 different paragraphs. If I look at tags at 0, look at that very first paragraph. Look through here. There are no A tags inside of this first paragraph. And so we don't add anything to the accumulator the very first time around through this for loop. But if I look at tags of 1, then here is my second P tag. Inside the second P tag, there is this A tag right here. And so we'll be adding this A tag to the accumulator. So again, this is very simple CSS right here. It's simple Python that you've seen before, but combining both of those two things together, you'll have to just look at it and practice some of those problems to make sure that you can do that combination. Any questions about that? Okay. So here, when this is sort of like, I think of this as a nested for loop, that this or a nested CSS selector, this selector, I'm looping over the results of this selector. And so I need a for loop to do that. Anytime you see this sort of like nesting-ish pattern with this for loop right here, looping over a previous result, then you should think about that as being equivalent to the space CSS selector. Down here, the very last problem on this practice quiz, there's multiple CSS selector calls, but there is no for loop here. All of these CSS selector calls are over the original soup, like the entire document. These selector calls over here are over individual tags, not the entire document, but the result of a previous CSS selector. So when you have multiple selectors that are the result of a previous CSS selector, it's like using the space combining CSS selector. When you have multiple CSS selectors that are on the original document like this, then it's like using the comma CSS selector. So this is going to be not equivalent, but very similar to P comma dot bold. The difference is that this is not going to remove duplicates. Both of these two things are going to return lists for me. And when I add those together, adding lists together just concatenates them. It doesn't look for duplicates to remove them at all. And so, yeah, there will be duplicates included. Down here, let's leave Python tutor up arrow, rerun it. So if I look at tags 1 is going to be all the P tags. We've seen previously that there are 2 of these P tags. If I look at tags 2
tags 2 is going to be all of the things that have the bold class. There are 2 spans with the bold class, span, and then there's also a p tag with the bold class. So this p tag right here is contained both in tags 2 and in tags 1. When I concatenate it together, it's not going to remove those duplicates. And so when I take the length of that, I have to count that p tag twice because it matches both of these. So this 5th problem, very, very similar to the 3rd problem, except that when I do this manually in Python, the duplicates don't get removed. Any questions about that? Okay. Again, for the quiz, the Python code is not going to be any more complicated than this. You'll just see these patterns, and the other practice quiz sheet has these patterns on it that you can practice. But for the actual assignment, you'll have significantly more Python code. I think my solution runs around 300 lines or so. In practice, you'll have to be working with things more complicated than this. And again, that video will go over those details. See, we have about 5 minutes left, and there's not going to be enough time to finish this discussion, but I want to start talking about just a little bit about how the internet works in general. This is not something that's going to be like, I don't know, appearing directly on a quiz or assignment somehow, but can help you with like debugging, just general understanding of how things work. And the example that we'll use to see how to like motivate all this is that pretty much exactly a year ago, Facebook went down for 6 to 14 hours. If you're a Kakao user, is the Korean sort of equivalent to Facebook, Google. It went down while I was over in Korea. Everybody in Korea panicked. But Facebook, a little bit more important. Yeah, so down for 6 to 14 hours. It was such a big event that it has its own Wikipedia page about the Facebook outage of 2021. The estimated loss of revenue for Facebook, $90 million, that they didn't get to serve ads during those 14 hours. But an even bigger deal for Mark Zuckerberg is that Facebook stock fell 2% as a result of the outage, which cost him $7 billion because of this outage right here. And so way back again at the beginning of class, we talked about like, okay, the like engineers who work at places like Facebook, they get paid a lot of money. And why is it they get paid a lot of money? We've talked a little bit about that. But like, I don't know, for $7 billion, Mark Zuckerberg could have hired 1,000 engineers at these really great prices and not hit anywhere near $7 billion of lost revenue. If adding 1,000 new engineers to Facebook makes the chance of Facebook going down just a little bit less likely, it's a rational thing for him to do. And so he is very willing to hire many, many engineers at 7-figure salaries in order to prevent Facebook from going down. Facebook itself, so fairly complicated software. Here's a chart showing about lines of code of typical software. So like a typical app on your phone, maybe about 40,000 lines of code. Facebook itself, 61 million lines of code. Again, no individual person can understand all of those lines of code. Certainly not Mark Zuckerberg, but not any other contributor to Facebook. And so these sorts of problems happen. Yeah, Facebook's more complicated than like the space shuttle, only 400,000 lines of code, or the F-35 fighter jet, 24 million lines of code. Let's see. I don't know. You can read the other ones about what's maybe most important to you, but yeah, lots of lines of code in all these big projects. And that'll be a good spot for us to stop. Next time we'll talk about like, I don't know, just how the internet's actually connected and what happens. If anybody has questions about anything, then I will take them now. Otherwise, I will see you all